Alright, hello everybody, welcome again to another live coding session. And this time we will continue our investigation of adaptive cards rendering in UNO platform. Last time we got quite far in the basics. Basically, we took a look at how adaptive cards are implemented for WinUI and UWP. And we actually started porting this adaptive text block render part of it. So rendering of a text into the card. So that's the most basic kind of output that you can have in a card. And I would like to continue on that and try to get as far as possible to actually rendering a simple card within UNO platform today. And I actually have here, it seems that there is a, it's suggesting some code to actually display a simple card here. So I will install this adaptive cards library, which is the .NET standard library that allows you to construct cards and then export them into JSON. There should be some kind of to JSON, yes, to JSON. It serializes that card into a JSON string, and then you can get that to render. So JSON string, and technically I should be able to do something like yeah, exactly like this. Thank you for the Copilot, that's very helpful. The Copilot is very helpful here. So in here I should be able to add a reference to that rendering WinUI library that we created, and then using that we should be able to get it to render basically the same way as it's done here. So they create a adaptive card renderer, which we don't have yet. Then we take the card from a JSON string, and then we render that adaptive card into a rendered adaptive card instance, which contains a framework element, which we then just put into the UI, and it becomes the adaptive card being rendered as part of the UI of the application. So it's several steps, and I think that the best way to start is to actually start with the adaptive card render class, and then take our way through it to get to actually to the rendering part itself. So I will find that class. I'll actually open our test application here as well, because we created that last time to play with the adaptive cards library, the production one, the one that's provided by Microsoft. So we will take a look at how the class is looking, and then also use the source code itself to understand what's there. So I will search for adaptive card renderer, which is here, and I need the one that's available in UWP, I'm pretty sure. Yes, so this is the adaptive card renderer. The implementation of that particular class doesn't seem too complex, but there is a lot of dependencies, of course, so it's not completely as simple as it looks. So what I will have that here. That's the adaptive card render component. These are the important part for implementation, and then we need also IDL file, which is for rendering, and then we search for adaptive card render, which will show us the the public interface of that class. Sorry. Okay, so this is a class. I will take this whole thing and just implement it in created that public interface for it. So I will call that adaptive card renderer. And now its implementation. Let's just spawn this whole thing there. Get rid of this. Get rid of that. We don't have to implement everything. We just need to implement the crucial things, and the other ones can stay not implemented or commented out. So it's not a big deal. It just needs to be there later for compatibility reasons, of course. But for now, we can probably just comment out everything except for the thing that we will actually use, which are these methods right now. Rendered adaptive card from JSON string, and I guess this one can stay also unimplemented because we will be focusing on the string-based rendering, not JSON, because that JSON object is coming from UWP, and we don't have that yet in Uno platform. We have only like the stub for those objects, but this whole namespace, this Windows data JSON, is not yet implemented, and we will have to do it one day, but not right now. So we can skip that for the time being. Let me search for rendered adaptive card, because that's another class that we'll need to have. So this one, rendered adaptive card. And what I will do here as well is that I will just try out the... Oh, this is not the right one. Ah, right, this is the wrong test application, not the one that I wanted to have. I need to have a... Is this the one? I'm not sure. Let's try. I just need to find the test application where we were playing with the adaptive cards, so I can just verify that the code that I have here is actually something valid. So, is it the one that I wanted to have? No, that's definitely not the one. So let's see. Recent projects, and I have a lot of test apps created over my hard drive, so it's kind of hard to find the right one, but this should be it, I think. So I will put it here. Adaptive card doesn't take constructor. No, really? Let's see. Adaptive card BMI free. Right. Object model BMI free. So it's just the wrong one. I need to add a reference to adaptive cards. This one. Accept. And now we should have it correct. So adaptive cards. Now it says block, and then to JSON. This will give us the JSON string, and now we can render it using renderer. Card renderer. Renderer will render adaptive card. So there are 3 different methods for that. One takes the adaptive card instance, one takes JSON, and one takes the JSON string, and that's the one that we will use. So this will give us the card, and then if rendered card framework element is not null, we will just output it onto the page. So let's have a border here. Container and have a width of, I don't know, 300 and 300. So a square container with, background of red, so we can see it properly. And then I will say child of this will be the rendered card framework element. Okay, let's launch the application and see if it renders at least something. Yeah, right. It's just complaining about nullables. Click it. Yeah, and you have the rendered card with hello world in it. So that's good. That's very, very good. And so this code works, and we can definitely use it to verify the functionality when the application is actually working, because it's not yet there by far. There's a lot of code required to make it work, but at least you know that it's doing something. So let's put it here. The container, we have the card, and now let's implement the important stuff. So adaptive card renderer, then we have the rendered adaptive card. It's rendered adaptive card or rendered card. Okay, where do I find it? Here. Rendered adaptive card. No. Nope. This one. Render adaptive. Alright, I already created it. Really? Oh really? I did create it. Oh, it's there. I'm blind or something. Good. All of these need to be there, but we don't need them implemented for now. We just need a framework element, so nothing too special there. And what we will also need to have is, well, maybe implementing this part will be easier than the render first. So I will find the implementation of rendered adaptive card. So okay, there's a lot of code in there, but we will nothing special in the private code. So let's go to CPP. So the constructor, there are multiple constructors, only one is public. So rendered card. Adaptive card as a public constructor, yes. So framework element is get only. So essentially you only need to use it with the private constructor, because you need to pass in the actual data inside. But what I need is this one, set framework element, which will be setting the private backing field for the rendered card. So there is a private backing field, and then a method that sets that field. So this method there. So this comes from the header file. So there is, no, this comes from the header file. So I will have private framework element, Let's make the naming better. Oh, like more C#y, because they are using the C++ conventions. And have this internal method called set framework element set the value and just make it expression method. So this sets the framework element. It's going to be a public framework element class, and that's it. And this class, this field is nullable, so yeah, right, it needs to be nullable here. So this is a very simple implementation. A lot of things missing, but we don't have to care about that right now. And this set framework element is called from adaptive card render component, which is the adaptive card renderer that we are interested in. So let's skip this one. Let's skip and focus on this JSON string based version of that method. Card from JSON string. So let's just adjust the code so it looks correct. So this is the rendering part, and this is some error handling part. So again, let's ignore that. Throw not imply new not imply exception for now. And now let's go to adaptive card, which should be coming from the object model here. We don't have it yet. So let's create adaptive card. And it should have a static method that takes the JSON string and parses it into the adaptive card. So in the IDL, I should find it, of course. Right, it's not the right one. We need the object model IDL. Adaptive card. This is the whole adaptive card thingy, and it has this from JSON string method. So public static method takes the adaptive JSON and then returns a adaptive card parse result, which is yet another thing. Let's find it. This guy. So we have the adaptive card parse result. And that might be a quite easy class because it should be just a container for some data. So let's try to implement the whole thing now. So this is the header file, nothing groundbreaking there, just the data, and then the CPP file, which contains just nothing, just sets those values here. So it's very simple one. It just needs to contain all those things. So I will create those there, including the public constructor. Which is empty. This is the adaptive card. Yeah, they need to have also adaptive card parse result. The internal constructor, which takes all those values. So adaptive card itself, then errors and warnings. Adaptive error. So let's implement that again. We're slowly adding more and more classes that are relevant to what we're implementing, which makes sure that we're slowly will have less and less errors in the code until eventually we'll have everything green, because we will have all those classes in place, and it will be much easier to actually port new code, because those relevant things will be there. Okay, so this is a public status code, public message. So I think this is it. Let's check it in the sample application. So adaptive error has a constructor of status code and message, and then those should be read-only. Oh, those are settable, so it's get set. Same here. So interestingly, they are not read-only. Let's follow that API surface. We have adaptive error, we have adaptive error here. So this seems to be complete. And there was also adaptive warning. And that one looks like what? It's gonna be quite simple probably. So adaptive warning, again, warning status code and warning. So we don't have warning status code. No, the problem, we'll create it. And that's an enum. So public enum warning status code. Let's copy the values. Quite a few of them. Here we go. So we have warning status code and we have adaptive warning and adaptive error. So the parse result is now almost done. We just need to set those things. Okay. Warnings and errors are set. Inconsistent accessibility, yes, we need this to be public. And just to verify, let's find that. Oh, there's no constructor like that in. It's not public, right? So this, by default, this will be null. This should be null and this should be null. Let's check it just to make sure. So let's copy guard this, and then we have art rendered new rendered adaptive guard. Oh well, parse result. Yes, this one. There. So this should have nulls for values. Let's check in there. Okay. No, wrong thing. So it's actually not. It's actually an empty enumerable. IList. Yes, it's not null. It's empty list. So new. Oh, maybe let's do array empty adaptive error and array.empty the adaptive warning. So we're getting there. Adaptive card parse result is done. So now let's continue in that implementation of the renderer of the parser. So from JSON string okay, adaptive card CPP. This is the one that we need. So it takes JSON string and these weird things. Okay. So there is the public method actually calls another method there. Element registration and active registration. These are null, so it calls this one, which calls this one with underscore. Not very beautiful, but we can work with that. So now we need this class, adaptive element parser registration. Which is public again. Let's just see here. Yes, it's public and there's some methods. Set, get, remove, and yeah. So let's copy that from IDL. That's the public constructor. And now the methods. So public set method. We don't have the interface of parser yet. We will have to add that. We need this one. And we need this one. Probably very simple class. Just need to add those missing interfaces and implementation. So let's get on that. Right, that was that one. So I adaptive element parser. Yes, this is the unpleasant thing about this, as it takes Windows data JSON instead of the system text JSON or Newton's JSON. So this will bring about problems for sure. But for now, let's just use the full qualification, use this one. Maybe we will work around it somehow. But let's ignore that for now. Adaptive action parser registration. What is that? Oh, another similarly looking class. Interface. Oh, class. It's a class. You can see that the adaptive cards implementation is extremely modular. Apparently, you can swap out many things, many parts of it. Unfortunately, it's bound to that WinUI JSON interface handling. So that's the painful thing about it. But technically, if we implement a separate, if we have it as a separate implementation from WinUI or the Microsoft provided UWP implementation, then we could swap out all those JSON references for Newton's of JSON or the system text JSON, because it should have the same kind of behavior. So it shouldn't be a big problem. Just for now, it's gonna be all red all around until we find a solution for it. Okay, so if I list, slowly you can see that there's less underlines because we already have a lot of classes prepared. So it's getting easier and easier to make things compilable. Okay, so let's implement this whole adaptive element parser registration class. It should be just a storage mechanism, basically. Oh, it's more complicated than I thought. But maybe let's do first the action. Parser registration seems equally so or similarly complex. So doesn't probably matter which we take care of first. What is this? Shared model parser. Huh. Okay, this is some private class. So basically this class has a dictionary which stores some parsers that are then used to parse actions, and then also the adaptive elements, which is the separate one. And technically maybe this one will be easier. You can see that they are taking all those default parsers like action parser, column parser, etc., which are then used to parse different parts of the adaptive card. So let's go here. And maybe let's also take inspiration from the CS version from... that is our implementation, but we need parser from WPF, I thought. But I don't see it there. WPF. .NET library. Parser. It seems like WPF doesn't need it or use it somehow. Oh, okay. Let's take the implementation and then we will adjust for the header file. So, this is the constructor. And the set method. Then the get method. And finally, the remove method. Then this register default action parsers method should be private. Oh, okay, sorry. I was looking at the wrong file there. I need this guy. Okay, get rid of all this mess. Oh, maybe instead of this, we'll have this. And instead of this, we will have just this. Okay. So these are the default parsers, and it's gonna be called from somewhere, probably. So this is called from the constructor. Yes. This is my implementation. This is the one that we are using. And I don't yet understand the purpose of this whole thing, but we'll probably get there. This is a number of parsers, but yeah, right now we will focus only on the text block parser. So the adaptive text block parser. Let's find it. It's a class that implements iAdaptive element parser and has a constructor. Let's create a folder for that. Okay. It must implement iAdaptive element parser and have a constructor. Like this. So adaptive text block parser. CPP. The implementation is quite simple. All right. So it's using this from JSON method with some generic arguments like adaptive text block, and text block parser. So this implementation then takes that and it's in the adaptive element parser registration. So okay, so this is the shared thingy that we were seeing there before. This is the shared element parser, and this is some kind of like helper method that's taking care of the parsing. No, it's not really it, I think. If I go to definition, it takes me here, but it doesn't look like it. I don't think that's the one, that's the method. Input JSON is not a string, it's JSON object. Search for this. Huh. So what is this? Okay. We need to figure out where this method is coming from. It must be a generic templated method. Somehow. And it must come from so the shared thing is only this element parser registration. So let's go there. Yeah, okay. So in this header file there is this method, which then calls the string version of that. So element parser registration. Internal static So from what does it return? Oh, it returns a type of, okay, so T adaptive element, and it is called to JSON, from JSON. And now the types. So T adaptive card element, T shared model element, and T shared model parser. Now, as inputs, it takes JSON object, and these things. Oh no. So there is also a interface of iAdaptive class element parser registration. No. Okay, this is apparently some kind of weird naming convention thingy. Hello, MCNets. How are you doing today? Okay, so this is a registration class here. So this should be like this. This is additional. Oh, what issue? Maybe I might be able to help. I could try at least. So list. Identify property changed should work normally in Skia on any system. It's just an interface, so like the data binding should work fine. Community toolkit. Are you using the source generators there or not? Like the property change source generators, like the attributes for source generation. Oh, it's not valid. Now let's comment out this whole thing. Oh. Sorry about that. I'm not sure about the limitation, why it's... But yeah, if the community toolkit is... If you're using the community toolkit MVVM and you're using source generators there, it might be a issue there. That might be the source of the issue, potentially. Inerts. Okay, so this is kind of some kind of C++ wizardry that gets the instance or something like that. That's nothing really useful for us. So this is parse context, some kind of parser context. Then we deserialize from string. So essentially they take the string that you put into JSON, then they convert the JSON object into string again, and then deserialize from string. Seems like there's like unnecessary round strips there. Yes, if you're using observable object and property, let's see. Community toolkit. So the thing is that if you have these attributes there, this observable property attribute, something like this, it could cause issues because the MVVM toolkit is using source generators that generate the properties during compilation, but we also have source generators in UNO platform that are generating the XAML. And now when these two source generators are running in parallel, it means that in some cases, in many cases actually, the MVVM toolkit source generators are not yet done with their source generating, and we are not able to see those properties because they don't yet exist. And then you get errors and you cannot compile. And the other way around, it shouldn't matter. Any way you build, the source generators will be running, and if you use those properties in XAML, you can have issues. And so there are multiple different solutions. One solution is to skip using those attributes and just use normal properties with set property and everything. So you would like write this yourself, and then you will have no problem because you will be able to data bind to name, and it's like this thing is the same thing as this, it's just more verbose. So you can do it and it will work fine and as you expect it to. We have a workaround in progress, I think, from Yusuf regarding this. So let's see, Community Toolkit. I think there is actually an issue, and I maybe reported that. Toolkit MVVM. Yes, cannot compile, so generated. This is it basically. So yeah, they are trying to fix this part, but unless MVVM, I think I did an issue on this separately. Yes, this one. Oh, okay. So it seems that this will be supported, or already is on the latest version. Hard to say, but it should not work. There is some kind of workaround that makes it work, but I haven't tested it yet, and it seems that it may merged 2 months ago, so I'm pretty sure it should be in the latest release, latest stable release. So you can try, if you're not on the latest, then try the latest. But if you still encounter issues, then just use this whole for verbose syntax. And if you want to have it less verbose again, you can use Fode in property change. This one is injection and injects the necessary code for property change. So basically you just write this, and Fode takes care of turning it into this. So it adds the onProperty changed calls as necessary, and it's actually very smart. So if you have given names and you change it, it automatically modifies not only given names but also full name, because that one depends on given names. So it's kind of even smarter than the source generators that you get from MVVM Toolkit, and so that's pretty nice. But I see that, yeah, they are also switching to code generation in version 4, so it will have issues again in the latest versions. I guess then you will have to use the version 3, everything until version 4 to make it work properly. Like, this is a general problem, and I know that they are looking into it. The like .NET platform team and C# team are looking into a way to specify the order in which the source generators should be running, which will alleviate these issues. But for now, it's kind of problematic. So, yeah, you have to use workarounds like this. Yeah, like implementing the whole thing directly is easier, and you don't have to implement the interface. You can just still use like observable object, and then just implement the properties themselves specifically like this. That should be enough. You don't have to implement iNotify property changed and then the event and then all those things. You just need this instead of this. That should be fine. Yeah, no problem. Hope it helps, and if not, you can open an issue and we can help out there, or a discussion on the GitHub. So let's see, shared model parser should be of some type. Let's go here. So we have adaptive text block parser, and it's called with adaptive text block as the first element, first argument. Let's go here. So this calls parser registration. So it calls it adaptive text block as the first argument, then adaptive cards text block as the second one, and finally text block parser. And this text block parser is exactly what? I have no idea. Ah, okay, so it's hidden here in the text block H file. So adaptive cards text block, and this is a public thing or a hidden thing, or what is it? No. Object model, WinUI free. Text block. There's nothing like that. Oh, I'm not using VS Code. I'm using it for the browsing of the like Microsoft implementation of adaptive cards, but for coding I'm still using Visual Studio, the full one. The reason is that the Visual Studio Code is kind of good browser and kind of good like fast viewer and editor for simple things, but I'm still more comfortable in Visual Studio because it's just what I've been working in for years, so I'm still kind of staying there, at least for now, until it gets like Visual Studio Code, until it gets more features that I'm missing currently. For example, building and running, debugging WinUI applications is not really yet supported in VS Code, so that's one of the features I'm missing. Text block H. So this text block is a custom internal class that's used, and it seems to wrap up the text block element itself. So what is the base card element thingy? So this is a kind of base class for all the elements. Yeah, I can see that there is a lot of similarities between the UW, like WinUI and UWP implementation and the Java implementation. It seems that they took the same approach and they just replicated the logic just in a different language. And there's a lot of interaction. You can see there's another like layer of parsers, base card element parser that somehow parses the JSON string and then outputs the base card element and so on. There is a lot of interaction hidden there. Let's see. I will try to see what the parse context is. So parse context is a context for the parsing process of adaptive cars. So let's find that here. Okay, so that parse context should be in the object model and it's public. So why it's not showing up in the ideal parse context? It's definitely there. That is weird. No. So we search in IDL files. Okay, that's kind of odd. It should be in the IDL if it's public, but it's not. Okay. Let's first get in this this enum container bleed direction. Again, it's not there. What is the wrong weird thing here about this class? It seems it's in enums. And then these are also public? No, this one is private only. Internal. internal enum. All right. Huh? So parse context again. We need that CPP class. And let's take all of that here. Ah. A lot of documentation in this class. Apparently the ID generation thing is complex. This is the parameterless constructor. And so these are some kind of private fields it's using. Okay, a lot of code. But the parse context doesn't have other public constructors here. So I don't understand where it comes from, because it should be in the IDL to be public. And if it's not there, how does it become public? Wrap maybe this part. Container. Really not sure. It's some kind of magic there. C++ is all magic, so I'm not really surprised that much. Okay. So let's give it a few more minutes, just so we continue with something. But you know, getting that text block to be rendered, it's not gonna be that easy after all, because you can see that there is a lot of code involved, and that parsing, I would like suppose that it would be quite simple, because it would be parsing from JSON using a standard JSON parsing mechanism into some POCO classes in a C#, but it seems there is more to it. Maybe taking inspiration from the WPF parsing might not be the worst idea after all. Let's see, text block. There's also some kind of magic there, but you can see that it's using JSON property, and it's using Newtons of JSON for parsing, so at least in that regard it's simpler. The font type default. So it's probably parsing using JSON, Newton just JSON, and we search for adaptive card renderer here. Has some resource magic, it has some rendering, and now we have render card. Render card. Render card. from adaptive card. So you get the card, you create a render context, and then you render it here. So maybe we could, what we could do is to make this even simpler. We could skip the parsing for now, at least. It's no, we would get to it later anyway, but we could skip that rendering, the parsing, and just do the rendering of an existing instance of adaptive card, which would be this. So adaptive card render here, render adaptive card. So this takes an instance of the WinUI free adaptive card instead of the one that we created here, which comes from the .NET Standard library, but it should be the same thing almost. So okay, this should be it, and now there should be something like text equals this. So it's just the same thing, just in different syntax. So I guess what I will be able to do now is to do this, and the rendering should still work fine. So let's see. Okay. Click me and hello world. So this is a simpler, even simpler code to render it. So I will go into where? Here. And instead of using this library, I will use our object model library instead. This one. And use this with text equal hello world. Close it. So this code should compile, and it doesn't now because we don't have many of those classes in there. But render adaptive card, this should be it. So adaptive card is the one that we need most. It's in the object model, and it should have, oh, okay, let's find the public interface in the IDL. UWP, and I want WinUI free. So whatever. Search adaptive card. Oh, adaptive text block was there. That was also useful. Adaptive text block is the one that we will need afterwards anyway. Adaptive text element is an interface that encapsulates some general text properties, I guess. Yes. So this one we will need. So adaptive text element, if I search for it here, it exists, so it's public, so that's fine. And now just set those. So these are nullables? Yes, so these are nullables. And font type is an enum that we don't have yet. So status code. Yeah, we have quite a lot of those enums already. That's pretty cool. So it's visible that one. Let's add one more. I tend to jump from one thing to another. It's kind of erratic, but you know, every single enum, every single class that we create takes us closer to the whole implementation. So it doesn't really matter that we are not too methodic in the ordering of what is done. The final result matters. Just need to make sure that we don't skip anything and nothing is forgotten, like the uncommitted code and these things need to be there eventually, just don't need them to be there immediately. Right, so adaptive text block. Text block. All right. What I will just quickly check is what's the approach they took in WPF for these specific classes for adaptive text block, for example. So the renderer is of course simple, but it takes adaptive text block, which comes from adaptive cards library directly. So they kind of skip this whole level of interaction of by using adaptive like the classes that are coming directly from the adaptive cards library. You know, this one is probably not the .NET standard one. I suppose it's probably specific for WPF, right? There is some CS approach. No. Yeah, here we have one. Okay. So this one. Is it the one that's used everywhere? Let me check that. It should have newtons of JSON as a reference in case it is. Oh, it has. Okay, so they are using directly this adaptive cards JSON like library instead of using the object model implementation. That's WinUI specific. So I wonder technically if we could simplify our implementation of adaptive cards by using that library directly, forcing newtons of JSON this way, and then doing just the rendering part, but use with different interface, different API. But we could implement it still for all the targets of UNO platform, including WinUI, so it wouldn't. So users that target UNO could still use one single library everywhere and one single code everywhere, even though it wouldn't be exactly the same as what WinUI is using. So instead of getting JSON object with Windows data JSON, we would be getting J object in newtons of JSON. And that would mean things would be simpler for the implementation part, because we could focus just on the rendering and the parsing could be done in the same way as WPF is doing it. So food for thought there. So anyway, just go back here. Text block renderer, render context. What I was trying to accomplish here, the renderer, and I wanted to see how to implement the render adaptive card method. So there's this one. Because I'm in the wrong. Adaptive card renderer. I need this one. Let's search for this. Okay, so this is the implementation of the method. So I will take it, put it in here, and let's just replace the things that we know. There's also some XAML builder as part of the renderer. Yeah, simple enough, this one. Of course, it's still a lot of red color there, but it's much more reasonable than the parser parts. And then we have XAML builder that's building XAML tree from adaptive card with render context and XAML builder. So yeah, this one seems more reasonable and easier to accomplish. Just, it's still a lot of code to do, but I think that this approach could be a good way to go, a good way to start at least, because we could do the adaptive cards. Render adaptive card, get the render to work, then make the XAML builder, because that should use XAML rendering that we have already in Uno platform, and then we will get the framework element. So that shouldn't be a huge obstacle. So yeah, I think that's something we can work on next time and continue on this. So yeah, I think for today it's enough code. So thank you for joining this session. And if you have any questions or any feedback or any ideas what to do next time or what to look into as a side project, because this will take quite a few live coding sessions apparently. So yeah, we can do 2 things or switch and alternate between 2 things, whatever. So let me know. See you next time. See you in MCNet and have a great day. Bye bye.